Okay, well, let's get started. It's 2 o'clock. Thank you, everybody, for joining this webinar. Let me start off with a little bit of housekeeping. If you look down at the bottom of your screen or somewhere on your screen, you should see a panel. And there is a button that says Q&A. So I will go through my slides and my presentation, and we will have time for question and answer at the end of the presentation. So feel free to put questions in as we go. I'll be looking at those. You can also chat among yourselves. If you see where it says chat, go ahead and do that, but I won't look there for questions after the presentation. And we get all the questions that are in the Q&A, and we can print them out, and we can respond back to people if we don't get all the questions. You'll also see at the end of the presentation my email address. So if there's anything that didn't get addressed or we didn't cover today and you had questions about, please send me an email. And if I can't answer it, I'll get it to the right people. And let me give you a little background and history of this project. So I'm really coming to this project late. I'm really just the messenger right now. But there was a lot of people that started in kind of the concept and designed this project. And let me tell you who they are. And let me also acknowledge the USDA, because this is part of the funding for this project was from a USDA OREI, or Organic Research and Extension Initiative grant that was received by Iowa State. And Kathleen Dellett was the lead researcher that submitted this proposal to USDA for the OREI funding. But Brad Hines, who is a dairy specialist at University of Minnesota, was really the brainchild of this project. And really Jeff Moyer, who at the time was the farm manager at Rodale Institute, Kathleen Dellett and Brad Hines kind of got together and kind of had the concept and started saying that let's put something together for this project, and started looking at integrating crops and livestock in a systems approach. And let me just recognize some of the other people, the other team members on this project. Bob Turnbull, he runs the research station at Iowa State. Angela Shaw is a food scientist at Iowa State. I mentioned Brad Hines, who's a dairy specialist. Paolo Pagliari is the soil scientist from University of Minnesota on this project. And Hannah Phillips was Brad Hines' graduate student, and she's done a lot of the work at Minnesota on this project and has several publications that have either come out or will be coming out soon as a result of this project. And from the Rodale team, when this project started, I wasn't here. I'm currently the chief scientist at Rodale Institute. Jeff Moyer was the farm manager. He's now been moved to be our executive director. Ross Duffield took over for him as farm manager. So for the majority of the project, Ross was the farm manager and oversaw farm operations here at the Rodale Institute. And Chris Nichols was our previous chief scientist. And Jennifer Hayden and Sarah Rocker, who I apologize, her name didn't make it here on the screen, did some great work looking more at they're both rural sociologists that looked at some of the barriers that exist in integrating crops and livestock in a systems approach. So that's the team, and I'm grateful to have come in and been part of this project, and recognize that there was a great great amount of expertise on the people there, and I may not have the same expertise. So as I go through this, you'll see that it might be them that might be better to direct questions later on. But the objectives of this project are to increase cattle nutrition for organic grass-based beef and increase the economic returns by reducing costs of production. And then those somewhat go hand in hand, because we know that in an organic system, the feed costs are much higher than in our conventional system. And so that can be a barrier to keeping livestock organically. But if we can put animals on grass and improve our forage in an organic system, the organic system will be more competitive economically. We also know from previous studies that adding livestock can, if done properly, can improve soil health. So our thought was that if we can add livestock, we will improve nutrient cycling, nutrient retention, and carbon sequestration, and basically make those nutrients more available by using livestock to the next crops. So I'll discuss the experimental design, and you'll see how we tested that. And we also wanted to look at food safety and nutrient quality, and I'll cover why we wanted to look at that over the next few slides. But what we've known is that, or what we're seeing is that there's really a need for integrated crop livestock systems, not just in organic, or really not just conventionally, but in organic systems as well. So, a radical shift occurred 70 or more years ago with the Green Revolution, and really the start of a chemically based farming approach. And that's really where kind of the genesis of organic agriculture started. But in the last 30 years, there's been a shift to greater specialization. So there's more farms that are specializing either in just livestock or just crops, and approximately 88% of farms now specialize in just crops or livestock. In 2015, only 8% of farms reported income from more than 4 crops. And so what we're seeing is that there's less diversity on farms. There's less crop diversity that exists on farms. And my last point there is saying that is showing the increase of farms producing only livestock. So this is in the last 30 years, the last 3 decades. This is the percentage of farms that are only producing livestock. So really what that means is they're relying on purchasing feed in and bringing feed to the animals, which is a whole host of problems that usually probably means that there's greater levels of infrastructure and manure management that is necessary. What we're finding is that this is the way the industry has gone, but it's also the way the organic industry is going. And the feed costs for organic are much higher, and if you have to rely on purchasing all of your feed costs, it can be difficult. Certainly is going to increase costs and potentially expense to the consumer. I wanted to include this slide too, because I also think it's important to look at the impact that farming systems are having on global warming. And so this is a recent study that came out that was a meta-analysis looking at all agricultural production systems and the carbon footprint of those systems. And so what this graph is showing is the greenhouse gas emissions per 100 grams of protein produced of different systems. And what I wanted to there's a couple of things that I wanted to point out here is, if you look at the ruminant, certainly recognize that beef production can have a very high carbon footprint. But if you look at the ruminant production, beef from a dairy herd actually has a much lower footprint than sheep and beef cattle. And if we follow down that graph, the 10 percentile of beef dairy herds can actually be below some other systems as far as carbon footprint. And then now this study didn't take into integrating crops and livestock. So certainly this study specifically has soybeans and corn. So there's grain and soybean production, and maybe I'd point you to tofu here, which has a very low carbon footprint. So, my point overall is that potentially by integrating crops and livestock, we have the potential to reduce our carbon footprint. But I wanted to bring these are the points that were made in the paper, and actually some of the points that I took out of it, that the greatest potential for reducing greenhouse gas emissions comes through diversified crop rotations. So that's directly opposite of the way the industry is going. The industry is becoming more specialized and less diversified. And we know there's tremendous importance for diversifying crop rotations from, fertility, weeds, insects, and disease management. And organic systems need to rely on these diverse crop rotations. And then the other one was improved pasture management. So globally, if we can improve pasture management, there's tremendous potential to reduce greenhouse gas emissions. And that's one of the things this project was really looking at, was improving pasture management. And so the other reasons why that we think this project's important for organic systems is that the National Organic Program requires that more than 30% of dry matter intake for ruminants come from pasture during the grazing season. So we take that to mean during a time when the grass is actively growing and the animals are grazing on growing, not just grass, but forages. And studies have shown that grazing on good pasture can be the most inexpensive or cheapest feed source. And the other thing, this study used dairy steers, although it wasn't necessarily set up to look, to specifically look at dairy. That's what we have available to us here in the states that participated, and we're seeing that 13% of all the organic beef is coming from dairy steers. And I'm making a point here that crossbreeding has become popular, probably for a number of reasons. Probably one of which is the health aspects of the milk, but also potentially the fact that there's dual purpose in those breeds. So you'll see why I mentioned that later, because we're going to give a little bit of information that was done at University of Minnesota based on the crossbreeds that they've developed there. But certainly there's also interest in grass-fed or grass-based production systems because of the health implications. And so we know that let's just say that the typical American diet, if we jump down there, we know is not balanced from a standpoint of omega-6 to omega-3 fatty acids. So I'm not a nutritionist, not a food scientist, but if we just look at the data, it shows that the typical American diet has a omega-6 to omega-3 fatty acid ratio of 16:1, and that's really out of whack. A healthy diet, what food scientists tell us, is that we should be closer or below a 4:1 ratio of omega-6 to omega-3 fatty acids. And that's one of the things we see is that research tells us that animals that are produced on grass have a higher omega-3 fatty acid content, lower omega-6 fatty acid content, and therefore giving us a better and more balanced omega-6 to omega-3 fatty acid ratio. But also there's, why grass-fed beef hasn't been adopted more, probably a lot of it has to do with the perception of carcass quality, and that you can't have a consistent high quality product raising animals on grass. Certainly there's some validity to that. Grass, depending on where you are, grows at a different rate. Different forages grow better at a different time, and that certainly impacts the flavor and the quality of the beef. But that's something that this project wanted to look at, and we'll be talking a little bit about that and showing a little bit of data on that. And so the twist that this project made, or kind of what this project was looking at, was grazing animals on small grains. So winter annuals in this case. We looked specifically at wheat and rye. And we have heard from a lot of different farmers that they're starting to use, well, a lot of organic farmers were already using rye or wheat or triticale as a cover crop. And they started saying, well, hey, why can't I put my animals out there and graze? You can see from this graph that it can extend the season, and with these winter annuals, you can either get into the field and start grazing earlier in the season or later in the season. And we know that farmers sometimes are taking these crops off for haylage, which if you're relying on stored feeds in a dairy situation, for example, then maybe it'd be good to get an earlier feed while you're waiting for things like corn silage to be harvested. Also, we're talking about improving or diversifying our crop rotation. So now if we can include a small grain into our rotation, maybe into a livestock production that normally or typically doesn't really need a small grain, but use it for something that more useful for the farm, it also has a benefit of improving the soil health. So we know that including pasture and including small grains reduces leaching and erosion and improves and builds soil compared to larger grains like corn and soybean. And it seemed like small grains also were a good option, especially for getting early season grazing, because studies have shown that the quality of small grains is higher earlier in the season. So crude protein and neutral detergent fiber digestibility tend to be higher earlier in the season. So we look here in these rings, this is probably where we have the highest quality, where we would expect that especially if we were raising high producing dairy animals, we would want our forage to be. But we understand that we have to balance it between biomass production and forage quality. So if you look here on this graph, April 9th, today's April 10th, right? So we're right in that range of ideal forage quality. However, if I go outside today or when I walked in and past the fields, most of our rye and our wheat is only an inch or 2 inches high right now. So probably if we put animals out, we wouldn't really be much there for them to feed on. So we're looking probably maybe a little bit later in the season, recognizing that when we get into the middle to the end of May, that forage quality might decline pretty significantly when the small grains start to go into a heading stage. So in this picture here, we see the Rodale Institute. The Rodale Institute is located in Kutztown, Pennsylvania, and it's a 333-acre research facility. It's outlined in green here. And in 2012, with some NRCS EQIP funding, we were able to fence in a large portion of the property. So if you can follow my cursor, this whole area here and some areas up here and here are all now fenced, and we're flanked on both sides of the institute by organic dairy farms. So this organic dairy farm particularly can now utilize this land, and there's actually fencing that can get these cows up into these fields. And so the red box represents our research area, and the other thing is that we use dairy steers because we are in an area where there's high amounts of dairy in Pennsylvania, and that's something that's available to us. So this field had gone into pasture in 2012 after we had the fencing in place, and you can see that these fields are mostly being utilized by this dairy farmer, and he's following an integrated crop livestock system. These fields here get plowed. You know, they've been plowed, and he's growing corn and soybeans, but he can rotate that into pasture and hay crops as well. And so, to give you the experimental design, what the rectangle you see here is basically that rectangle you just saw on the map. We started in 2015. The whole thing was a pasture, and we had two systems that were split. This field was split in half and had two systems. One that went from pasture into rye as our small grain. Then it went to soybean, and actually rye was planted as the cover crop after rye was harvested. And then it went to soybean, and then it went back into pasture. This other system was pasture in 2015. In 2015, wheat, the fall of 2015, wheat was established. That then got planted to vetch before we used that to plant corn. And then in 2018, everything went back into pasture. And what you also see are these exclusion sites. So the red boxes were areas that the animals were never allowed to graze on. So in 2015, the animals grazed on this land. These were dairy steers that grazed across these fields, and they went from each one of these boxes is a paddock, so they moved across the field. If you're looking at the picture from left to right or from west to east, and where the way we're situated at Rodale, but where the exclusion sites were, they never were able to graze. And So we basically planted that field in half, one side into cereal rye, the other half into winter wheat. And if I walked out into the field right now, this is almost exactly what our fields look like today. So our rye and our wheat have, we had a little warm spell here, and they've really taken off and are starting to grow. And then in 2000, and so that, if I back up a second, all of the rye and the winter wheat were all established in the fall of 2015 after the animals grazed through the pasture. In this system, we use moldboard plowing to prepare the fields at all times, although we use the organic rotational no-till system using the Rodale roller crimper in order to plant our corn and soybeans in the third year of the project. And I'll describe that more when we get there. So in 2016, though, now that we had rye and wheat established, we then further split the field into area that was grazed and an area that was never grazed. And then you see the G1, G2, G3, and G4. Those are basically the time when the animals were on those paddocks and were grazing. So that means that they would be grazing in those paddocks at different times of maturity of the small grains. And here you can see it at Rodale, just when we were starting on the first day when the cows were introduced. If you look on the left panel, you see that we used solar, electric, and portable fencing using these pigtail fences to block it off. So on the left side, everything to the left of that fence is ungrazed. Everything to the right is grazed. If I were to just kind of make a 90-degree turn from the location that I am on the left, I actually see what our picture is on the right, and you can see that we have rye in the foreground and wheat in the background. We have wire that separates the two groups of dairy steers, and we had 8 steers in each paddock. And this was the second day, so you can see to the right the animals had already grazed down for one day that paddock, and then we'll go ahead and go in and put the back fencing up after the animals move. They quickly moved, and we're really happy to move into the new fresh forage every day. And here are pictures from University of Minnesota Research Station, and you can see the similar setup: rye on the foreground, wheat in the background, 2 different sets of cattle. You can probably just make out a single strand of wire, so these are separated by a single strand. One thing that differed a little bit from Rodale and the Minnesota, Iowa State sites is that Rodale tried to mimic a mob grazing or a high stock density, and so move the animals every day into a new paddock, a new smaller paddock, where in the Iowa and University of Minnesota sites, Iowa State and University of Minnesota sites, they were moved into larger paddocks, but then they would graze through the system and come back and graze over the field multiple times. I think probably they went 2 times through the field. And so here's the wheat halfway through the grazing season. You can see it's starting to grow. Animals are happy. And then here's in the case of University of Minnesota, the last day of grazing, which was June 13th. If you look at that picture, you can see there's a lot of heads on the rye, and that probably indicates that it's of lower quality for the animals at that time, for the dairy steers. And so I think one expectation was that rye does grow more vigorously, and so it probably put on more biomass than the wheat. What was found, though, and these results were similar across all sites. And I apologize. I think some of the points got moved around or shifted when I cut this into the presentation. But if we look at the complete biomass of, and this is this is weeks on the x-axis, so weeks when the animals started grazing, and total herbage mass in kilograms per hectare on the y-axis. If we took a compilation of all of the biomass over the whole season we found no difference between rye and wheat. But the rye produced more biomass early in the season, and the wheat produced more biomass late in the season. And I mentioned earlier about the trade-off between quality and biomass. So you can see here that the rye biomass is declining. So probably somewhere around week 3 or 4, which if we started, I think it was April 29th at Rodale and April 25th in University of Minnesota and Iowa State. So it's about the same time. Week 3 and 4 is getting to be the middle of May, near the end of May, and then 5 and 6 probably the beginning of June at this time. So if you think you're going to graze earlier in the season, rye is probably a better option. If you think you might put your animals on later in the season, wheat might be a better option. If we look at some of the forage quality measurements, crude protein was consistently higher in the wheat than it was in the rye. And again, as we expected, it drops over time. And this is total tract neutral detergent fiber. And so probably in this one, we want to be below 60. So early on, it may be a little too rich, so to speak. And then later on, for most of this period, this is in a good range for this forage quality measurement. But we just wanted to point out here that this is a period of no rainfall, and it looked like it impacted the forage quality. And so here's some of the comparisons between rye and wheat as far as forage quality. So what we were doing to get the measurements that I just showed was we were putting 3 quadrats down in each plot or each paddock that we measured before the animals moved on to that paddock. We clipped everything we could above ground biomass. We dried that, we ground it, and then we sent that off for forage analysis after weighing it and determining the total biomass. And so, like I showed already, wheat had higher crude protein, rye had higher fat, neutral detergent fiber, phosphorus, and potassium. But probably the takeaway from this slide is not that rye or wheat or one was better than the other, but was that all of them fall within a acceptable range for quality forage for dairy cows. And the one thing I noticed when I was out there is that it looked like they weren't really eating the rye that well. When you move the animals from one paddock to another, the wheat was eaten down to the ground, and a lot of the stalk was left on the rye. So we actually did the same thing with where we threw quadrats out on the ground and took all the above ground biomass a day or two after the animals were moved off of a paddock. And what this graph is showing is that, and this is all, most of the data that you're going to see from now on is from just from the Rodale Institute. But you're going to see our grazing dates, but rye produced more biomass than the wheat. It may not have been statistical, but you can see from the picture here, it produced more. And then post-grazing, there was still more rye there. But if we take the difference of the pre-graze and the post-graze, that was the amount that was actually consumed by the cows. So the cows are not actually feeding more on the wheat or consuming more of the wheat. It's either the same or even slightly more of the rye. So that was just a concern that I had, that potentially, even though rye produced more, the animals were eating more of the wheat. So let me go through this slide, and then I'll move on to the next. So the conclusions for forage quality was that rye yielded more in the early spring and less in the late spring, and wheat yielded higher in the late spring. There was greater crude protein for wheat, but greater neutral detergent fiber for rye, and the total tract neutral detergent fiber digestibility was similar between both forages. forage quality decreased across the grazing season for both forages. But basically, this was high quality forage, both the rye and the wheat, and producers can incorporate rye and wheat cover crops for spring grazing without sacrificing forage quality. And rye actually may offer more herbage mass if you're intending to do this in the early spring. And so after the animals grazed, they were allowed, the small grains were allowed to go to head and mature. And then we came through and we harvested these both by hand. We took hand yield measurements as well as plot combine yield measurements. And one thing I wanted to point out earlier when I was talking about the carbon footprint is that most studies have looked, when they look at organic systems, they show that organic systems have lower greenhouse gas emissions and lower energy inputs. But there's been a lot of recent publications that have come out that have said, well, even though that's true, because organic systems have lower yields, if we adopted in a complete organic production across the globe, we would have to put more land base into production, and therefore that would offset any of those gains that occurred from the reductions on a farm scale. So on a farm scale, greenhouse gas emissions are lower in organic systems. On a global scale, greenhouse gas emissions are higher than conventional systems. And that's all 100% based on the fact that these estimates assume that organic systems yield less than the conventional systems. Now, I reject that because our farming systems trial here at Rodale Institute has shown that over 39 years, there's no difference, there's no statistical difference in yields between the organic and the conventional fields. And most long-term organic farmers I talk to feel that they can get yields that are comparable or better than their neighbors. And when we look around at most of our research trials, we are getting yields that meet or exceed our county averages. So I'm pointing that out because we look at the grain yield here, and I'm going to go through the economics of this in a minute, but in the ungrazed area, so this is the area that was really following what we would call maybe a typical management. It had been pasture, it was planted to small grains, no animals grazed, and then we harvested the small grains. We had over 80 bushels per acre of wheat, and that's pretty impressive. Our county average, I'm going to show you in a second, was 66.2 bushels per acre, and that was the average between 2012 to 2000. I'm sorry, that's not the county average, it's the Pennsylvania average from 2012 to 2016. But before I get into some of those numbers, let's take a look at when the cows were put onto the paddocks at different times. So you remember G1, G2, G3, and G4 was kind of the time when, or was the time when the insects were introduced into each paddock. You can see the days there. G1 was the beginning 0 to 4, G2 5 to 10, G3 11 to 15, and G4 the days 16 to 21. And what this graph is telling us first is that we are getting about a 40 bushel or more decline in grain yield when we graze the animals. That doesn't seem to change for wheat, but rye, when the animals are on the field earlier, it seems to have a significant and drastic impact on yields later on. So the recommendation there would be that if you're going to graze rye, you might want to wait a little bit. So day 11 for us would have been probably the beginning, somewhere around the beginning or first or second week of May, is when the animals were in the G3 system. And so if we look at this and we say, okay, well, we have a 40 bushel decline when the animals graze. The average price per bushel was $4.64 in Pennsylvania during 2016. And so then we lost about $185 in revenue per acre. But maybe we made that up with the gain in weight from the animals grazing. We also could maybe make that up in if we have improved soil or improved nutrient cycling, our yields may be better next year. So we can't look at this and say, okay, there's a loss. But I did a little bit of an analysis, kind of back of the envelope, and created a range. These were dairy steers, so they really weren't bred to gain and be efficient beef production animals. But if we look at the gain that their gain during that 21-day period, it comes out to about $45, $46 of income that would be generated from that gain. So that certainly doesn't catch up to that $185, $186 range. But then I started thinking, well, a lot of farms are, and actually our neighbor, he pays a custom grazing fee to put his dairy steers out on the pasture, and that would have gotten us closer to about $128 per acre. So it doesn't completely offset the loss from the grazing, but it's a little bit closer. I didn't take into account the straw that was baled. So after the harvest, all the straw was baled off of this field. So there's an economic benefit of the straw. But I will say that there was more straw in the ungrazed area than there was in the grazed area. And I think that straw is pretty important in an organic system, because in an organic livestock system, you have to use organically approved or organic straw for bedding for your livestock. So that is an important consideration. So after the small grains were harvested, cover crops were planted. Where the rye had been, rye was planted again in order to be a roll down for soybean, and in 2017. And where the wheat was planted, hairy vetch was seeded as a cover crop in the fall as a roll down before corn. So let me explain when I say roll down, or I say organic rotational no-till or roller crimper, you get a better understanding. So let me stop for a second. This is hairy vetch that you're looking at, and you'll see that the hairy vetch is flowering. What we found from previous trials over the last couple decades is that if you try to kill the hairy vetch too early, it'll just regrow. So you have to wait until it's in about 75 to 100% flowering. And let's keep going here. And you can take a look at the roller crimper and the tractor, which is coming down the field. If I stop it again, what you see is on the background is the rye that's been rolled down, and soybean was planted directly into that. And again, the rye has to reach anthesis, or where it's starting to shed pollen, or if you roll it down, it's just going to pop back up. So the soybean has already been planted and been rolled down, and now Ross Duffield, our farm manager, is rolling down the vetch and planting corn directly into this rolled down hairy vetch. We're using a monosome vacuum seeder, so you could actually change settings for the different seed plates. The roller crimper is rolling down and killing the cover crop, while sorry about that. Let's see if we can, well, we'll watch it one more time. And so this is a one-pass operation, no tillage. If you're tilling in an organic system and cultivating, it could be 3, 4, 5, 6 different passes across the field in a year. And let's go to the next slide. And so the first thing we're doing is we're looking at soybean yields. So this is not, our yields were not really as expected. Where the animals had grazed, where the cows had grazed, we had reduced soybean yields compared to where they had not grazed in 2016, and also the exclosure where the animals had never grazed. So in 2015, they also didn't graze. So it looks like there might have been some benefit of the animals grazing on the pasture, but not a benefit of the animals grazing on the small grains. Again, I want to point out that most farmers, whether conventional or organic, would be pretty happy with a 40 to 50 bushel per acre yield in our area. And you can see we were over 60, close to 70 bushels per acre in this trial. So that's a pretty high yield for soybeans. The corn had a similar trend. The grazed system again was lower than the ungrazed system, and in this case, the exclosure where the animals had never grazed actually had higher corn yields. And again, to point out, our county average typically is around 140 to 150. So in these systems here, we're really exceeding the average yields in our area. This got even close to 200. We've seen close to 200 bushels per acre in some of our other research trials and fields. So we have with long-term organic management, we're getting pretty high yields in these systems. I think the takeaway here that we might have is that maybe the animals grazed and they took some of that fertility away. So we had expected improved nutrient cycling to have greater levels of nutrients available to the plants the year after they were grazing on the small grains. So probably the conclusions here are that the grazing significantly reduced small grain yield. The small grain yield was not made up for with a profit from either grazing the cattle or potential increased yields in the crop in the next year. One thing I didn't mention though, that typically here at Rodale Institute, in our small grains, we spin on or we broadcast clover or some other crop that might do well under the small grain canopy, so that when you harvest, it's there and it's actively growing. And that, if we incorporated that, maybe those cattle could have grazed 1 or 2 times more through that field, and would have been, we could have had captured that gain or the economic benefit. So I just put a question mark here. Is there a benefit of integrating a pasture phase in an organic crop rotation? I think there is. A lot of research shows that when you have a pasture in a rotation, especially if you include alfalfa, it substantially improves soil health and increases yields for the subsequent crops. So we need to explore the potential for greater grazing opportunity throughout the year. And we also took a lot of soil health measurements. This is probably University of Minnesota. One, because I'm looking at the cows in the background, it looks like they're cows. But also when I look at that soil probe, it looks like really deep, rich soil. And I know that University of Minnesota started out with greater than 9% organic matter in their fields. So in the fall of every year, we took soil samples using a probe similar to this, took multiple samples across every plot, created a composite sample, and sent those to University of Minnesota and the lab of Paolo Pagliari. And he did a lot of measurements. He looked at a lot of the standard like pH, organic matter, available phosphorus, potassium, magnesium, nitrate, ammonia, total carbon, total nitrogen, or total percent carbon, total percent nitrogen, CN ratio. We also looked at glucosides, phosphatase, or glucosidase, phosphatase, and sulfatase. And so these are enzymes that are emitted by microbes in the soil that create glucosidase, which breaks down carbon matter and makes nutrients more available, or phosphatase, which will break down phosphorus and make it in a more readily available form. And our thought was that while these animals graze, they would create greater nutrient cycling and then make those, and which really would grow the microbial communities in the soil to allow those nutrients to be more available to the plant. And what we really found though was that over the time, there was very little change in soil health measurements, both between years and treatments. the one thing we see that sometimes can be difficult is that all three of these sites were under long-term organic management. The Iowa site was starting with 6% organic matter. The Minnesota site was starting with over 9% organic matter, and the Rodale site was starting with over 5% organic matter. And when we know that we look around at the fields in Pennsylvania where we're located, and the standard organic matter is closer to 2 to 2.5%. So we have more than double the organic matter in most fields. And so these fields we started with were very healthy from a soil perspective. And we know that it's hard to change soil. The healthier it gets, the harder it is to move that needle. And then we also know that soil health is something that's being monitored over a long period of time. There wasn't statistically, but when I looked at it and just looked like from the eyeball, it looked like there was starting to be a little bit of decline in soil organic matter during the small grain and corn and soybean production. And some of that came back in 1 year of pasture. But I suspected if we had 2, 3, 4 years of pasture or hay crop, that would improve. There was some things like higher ammonium levels in the exclosure in Minnesota, but that was only in Minnesota. That we didn't see that in the other sites. In Pennsylvania, in 2016, after the animals grazed on the small grains, we found higher nitrates and higher glucosidase levels. But that was only in Pennsylvania. It wasn't replicated across all three sites. And when we did that again in 2017, that was gone. So and then certainly we saw decline in corn yields, and soybean yields. So it didn't really result in a something that was an economic benefit to the farmer. So they were pretty random. So we can't really make any strong statements about changes in soil health. There was analysis of food safety, and so I'll just make a brief mention of this. Interestingly, at the beginning of this study, we found that there's some concern amongst food scientists that putting animals out on pasture would result in contamination of the beef and potential human health risks, which to us, that seemed foreign. It seems like if you get them out, have them grazing on grass or forage like they were meant to, there should be a human health benefit as far as contamination. So we took fecal samples right from the pasture, right after they came off the forages, to see if there was any difference in E. coli or salmonella levels that might exist from foraging on wheat versus foraging on rye. There was no difference whatsoever. And all of the results indicate that there is a very low probability of any occurrence of contamination from E. coli or salmonella from these adopting these systems. And then there was no difference between the Minnesota, Iowa, and Pennsylvania sites. At University of Minnesota, they did some work with different breeds. So they had a purebred Holstein, which is also what we use, a purebred Holstein at Rodale Institute. But they also had a couple other crossbreeds, and I'm not an expert on dairy breeds, so I'm not able to tell you exactly why or what the benefit is, but certainly there was a reason for why these breeds were created, for the traits that they exist. And so there's 3 different breeds that were grazed. And when we look here, some of the nutritional quality, so all of the animals that were in the study were slaughtered and sent off for and the meat processed and sent off for analysis. The highlights of this graph show that the crossbred breeds had lower trans fat than the purebred Holstein. And again, I'm not a nutritionist or a food scientist, but I know that trans fat is not typically good, so the lower levels of trans fat is better. We found that the levels of omega-3 fatty acids were higher in the crossbred breeds than in the purebred Holstein. There was no difference in the omega-6 fatty acid levels between the breeds, and that resulted in a lower omega-6 to omega-3 fatty acid ratio amongst the crossbred breeds than the purebred Holstein. And what basically we're saying here is that there was a 14% increase in omega-3 fatty acids, no difference significantly in the omega-6, and a 14% lower omega-6 to omega-3 fatty acid ratio. So that was almost entirely, the ratio was almost entirely attributed to the increase in omega-3 fatty acids. And that out of place, but that's okay. And so the conclusions were that carcass quality was similar between breeds. As I mentioned, the crossbreds had 14% greater omega-3 and 14% lower omega-6 to omega-3 fatty acid ratio. The crossbred steaks were 6% darker. There was no difference in amino acids, were similar between breeds. And there was also some consumer acceptability studies that were done. So they actually cut the beef up into little cubes and then cooked them all exactly the same, and then had consumer preference and consumer taste testing work done, and showed that the crossbred steaks had greater consumer acceptability. So the ultimate conclusion is the crossbred dairy steers have a healthier fatty acid profile and are a viable option for the beef market. And so we also did a little bit of social work where we had, and this will be my last slide before I moved on because I know we're coming up on time, but so we did some surveys and also some focus groups of farmers that have integrated crop and livestock, and really came up with some of the challenges and the opportunities that are seen. So there was what was determined, and this was really run by Jennifer Hayden and Sarah Rocker. And there was challenges and opportunities that the farm can control. So things like farming norms, we're finding this in really across agriculture that there's farmers tend to not want to break with tradition. You know, they did it this way, their dad did it this way, my neighbor does it that way. And how are they going to be perceived by their community? But certainly integrating livestock has greater complexity, biophysical conditions, meaning, hey, now you're outside, you're not in a building that you can control, so you can't control the outside conditions as well as you can a building. And then the financial costs. Because certainly there's an investment that needs to be made that needs to get paid off over a long period of time. The opportunities, though, is that there's increasing support. Some of that's from consumers demanding grass-based products. There can be financial and labor advantages. So we know that 60% of farmers work or have jobs off-site. So sometimes animals, even though there's maybe more labor, it seems like there's more labor. You know, the animals are doing the work for you. You can improve the biophysical environment. So things like improved soil health, improved nutrient cycling, and certainly also improved animal welfare, which is an important aspect of organic production. Things that are out of the control of the farmer are regional infrastructure. So certainly we're challenged right now because we don't have very much infrastructure for processing of organic beef and organic livestock. The need for financing and insurance, a lot of times typical banks don't really understand this model. And then there's long time horizons for returns. So your costs may take a long time to recover those costs. But we are seeing that there's greater support for policy. There may be economic incentives, so you may be able to get a higher price for grass-based and especially organic grass-based products. And they're starting to become more of a social infrastructure. So with that, I'm going to move to questions and just say that there's my email. People can ask me questions, and that all the outcomes and output from this project are going to be housed at the Rodale Institute website. So we have not yet created that page, but we're in the process of of putting all these outreach and all the different outputs on the Rodale Institute website. So stay tuned, come back and see what we have there for project updates. And I can certainly stay beyond the 3 o'clock, because I went a little longer than I expected, but we have a few questions here that I'll go ahead and answer. Let me just read them real quick. So I'm going to start with Tom. Tom asks, have you thought of mixing cows with chickens? Chickens spread manure in the field and look for worms in cow manure, for example. Yes, we have. We know that there's farms that are doing that. We actually do have we do pastured layers, broilers, as well as poultry here. We haven't necessarily done a research project to look at that impact. So we've thought of it. I think it's a good idea. That's greater diversity on the field. And probably right now there's a lack of actual research to show the benefits of that. It's mostly farmer testimonials that are telling us about the benefit. And then the other one is, how about with other livestock? Do you have any idea about how pasture and fertility behave with pigs or poultries? So I will say that we have a pastured poultry facility on site at Rodale Institute. We have a research program going on with pastured poultry, and we're actively looking at that. In the next year or two, we will be comparing. We'll be taking deep soil cores in the area around that facility where the pigs have been foraging for several years now. We do have active research going on with that, and just a quick and dirty answer right now is that one goal is animal welfare. Certainly the way pigs are produced around the globe in confinement is not good for pigs. It's not, really, it's not the true intention of organic production. They should be out in a more natural setting. I didn't mention it here, but most organic farmers you talk to, when you put animals out on grass, their vet bills go down. So there could be a benefit economically from having the animals out on grass. What we are tending to find, though, is that the other thought is that by putting pigs out on pasture, their foraging will offset the need for grain, and since organic grain is high, you can get a 30% or so reduction in grain feeding. But at the same time, those animals are moving and they're being pigs basically, and so they are using energy, and so in some cases we actually find you have to feed them more feed. So it's certainly great for animal welfare, and it's inconclusive, I think, because we've really just been having them out on what we call standard pasture, but we want to start moving into them foraging on oats and peas, or summer annual plants that then grain, and they can feed down or hog down that grain. So Molly says, were the results of this experiment what you had expected, or were you hoping to find grazing increased yield? So I think we thought was that we expected that when the animals grazed on small grains, that it would reduce the yields of the small grain. I think that was certainly expected. But what we thought was it'll be made up for by the fact that we have increased meat production. So even though they grazed, there was still a product that was being produced, and that it would increase nutrient cycling. And so our corn and soybean yields would be higher the following year where the animals had grazed. So that was probably not what we expected. And some of the things I think we think about is, well, what if we had a better breed? These are Holstein dairy steers. What if we had beef cattle? Would they have had greater levels of gain? The other thought is, well, what if we do this, what if we're doing this for 20 or 30 years? We might actually be building our soil up. It's hard to see it in just a couple of years. A lot of anecdotal evidence shows that when you take really degraded land and put animals on them and and have pasture that you can really improve in a short period of time. So I think that answers that question. If you guys are looking, you see from Hannah, I'm just going to read it if you're not looking. The University of Minnesota just concluded our first research study investigating whether broilers reduce flies on pasture. Broilers did not reduce fly numbers. However, future research should focus on the effect of layers on flies because layers tend to be better foragers. Okay, so layers versus broilers. And yeah, we've seen that. All right, and then the first one, which I thought might take more time, so I waited, is would you go talk about sequestrating carbon through grazing cattle? So I don't know if I'm necessarily an expert. That study that I showed early on did not really consider crop integration. So I'd like to see a similar study or similar analysis concluded that would look at what happens when we integrate different systems. But certainly we know that the reason that we have these deep, rich soils in the Midwest United States and other areas that were perennial grasslands is because the animal impact that was on them. And so the animals grazed, they grazed in high stock density or high numbers. Those plants had very deep roots. If we just left those systems go, like if we went to the Midwest and just took animals away and didn't do any farming, they probably wouldn't remain grassland. They would probably turn into more of a temperate forest like we have here in the Northeast US. So it's the animal impact and to a much lesser extent, fire that kept those systems where they were. So, you know, grasslands in the temperate regions of the world tend to be the most highly productive ecosystems, have the greatest levels of carbon stored in the soil. And from other studies that I didn't present here, we see that the soil is the greatest source of carbon. We've lost a lot of carbon from the soil, and so we think that soil could be the greatest sink for carbon, or one of the greatest sinks. So if we improve our farming management systems, we have the potential to not want to say reverse climate change, but greatly reduce greenhouse gas emissions. And I don't see any other questions here, so I'm going to thank everybody for their time today and for listening in and sticking with us a little bit beyond the time. And I'll conclude the webinar. Thanks, everybody.